Good day, everyone. Today, I'll be going to discuss integration by parts. When we say integration by parts, it is a technique used in calculus to find the integral of a product of function in terms of the integral of the derivative and antiderivative. Basically, if you have an equation with antiderivative, two functions multiplied together, and you don't know how to find the antiderivative, the integration by parts formula transforms the antiderivative of the functions into a different form so that it's easier to simplify. So here's the formula. Integral of f of x g prime of x dx is equals to f of x g of x minus integral of f prime of x gx dx. So however, the integration by parts formula can also be written more compactly with u substituted of f of x and v substituted of g of x and dv substituted of g prime of x and du substituted for f prime of x. This one. So here we have an example. Now, find integral ex sine dx. So choose a u and a dv, which is u is equals to sine x and v is equals to ex. And find du and v, the derivative of sine x is cos x. So which is the du is equals to cos x. And the antiderivative of ex is still just ex. So means dv is equals to ex. And then enter those variables into the equations or to the formula given be. So it looks worse, but let us persist. And the integral of cos x ex dx part of the equation still has two functions multiplied together. Sometimes, when you use the integrate by parts formula and things look just as complicated as they did before, with the two functions multiplied together, it can help to use integration parts again. So let's try it. Focusing just on the integral of cos x ex dx part of the equation, choose another u and dv. The derivative of cos x is negative sine x and the antiderivative of ex is still ex. So we have u is equals to cos x and dv is equals to ex and du, and the derivative of u is equals to negative sine x and v is ex. Plug these new variables into the formula again. So in this, plug into this. So we have this one. Sine x ex minus cos x ex minus integral of negative sine x ex dx. Now simplify. We have integral ex sine x dx is equals to ex sine x minus ex cos x minus integral of ex sine x dx. And then we can move the negative integral ex sine x dx from the right side of the equation over to the left side. So, we have 2 integral of ex sine x dx is equals to ex sine x minus ex cos x. Then another simplify. So we get the answer ex sine x dx is equals to ex sine x minus cos x over 2 plus c. So let's have another example. Find integral x squared ln x dx. Again, first we'll choose AU and ADV. So RU is equals to ln x and dv is equals to x squared. Then we'll use that information to determine du and v. The derivative of ln x is 1 over x dx. And the antiderivative of x squared is 1/3 x cubed. So we have now that we have all the variables, let's plug them into the integration parts equation. Integral of x squared ln x dx is equals to ln x times 1/3 x cubed minus integral of 1/3 x cubed times 1 over x dx. And that's left, all that's left now is to simplify. First, multiply everything out. So we have x cubed, quantity of x cubed ln x over 3 minus integral of x squared over 3 dx. Then, take the antiderivative of x squared over 3, add the constant, and we got the answer. So we have x cubed ln x over 3 minus 1/3 x cubed plus c.